Hello and welcome to my science tutorials. In today's video, we want to look at pressure. Now before we begin, if you're new to the channel, kindly consider subscribing and turning on the notification button so that you do not miss any of our latest tutorials. Alright, so let's begin by looking at what pressure is. So pressure can be defined as the force per unit area. So we define pressure as the force per unit area. So if you want to represent this mathematically, it means that mathematically we are saying that pressure is equal to force over area, where our force here, let me rewrite that, where our force is measured in newtons. So our force is measured in newtons, capital N, and our area is measured in meters squared. So what this means is that when we are given a question and we have to calculate the pressure, we need to make sure that the force is in newtons, okay, and then the area is in meters squared. It is very, very important. Now from this expression we can see that pressure, or we can make some deductions. We can say pressure is directly proportional to force. That is, pressure is directly linked to the force. So the higher the force, the higher the pressure. And then we can also say that pressure is inversely proportional to area, which means that if we have let's say a material or an object that has a very small area, because of this relationship, pressure and area being inversely proportional, small area means there will be a high pressure at that particular area. This is very true, as we can see some examples in real life. For instance, you can see that a pin, because it has a very small surface area with a minimum amount of force, is able to produce a very high pressure. Okay, so you can see that because the surface area of pin is very small, you always, mostly with a small force applied, you realize that the pressure exerted onto that particular surface area is very high, or it can be able to penetrate you. While if you take a pen, let's say a pen, the tip of a pen, because the surface area of the pen is the tip of the pen is a little bit bigger, the pressure over there, or the pressure applied, is very small. Okay, that is unless you increase the force very largely before the pressure will also increase. So what it means is that if we have a very large area, that area will exert a very small pressure onto a particular surface. And if you have an object with a very small area, that small area will exert a very high pressure onto a particular platform. Now before we continue, we know that area, let's just do some quick recap. Area is length times breadth. Okay, so let's keep that in mind. All right, so let's have a look at some examples to see how we can apply this formula that we are saying pressure is equal to force over area. Let's see how we can apply some of this formula to solve some questions. So let's have a look at the first example we have for this tutorial. So we have a plastic block weighing 25 Newton, has dimensions 34 centimeters by 25 centimeters by 10 centimeters. What is the greatest pressure and the least pressure it can exert on the ground. So let's have a look at the solution to this problem. So write down our solution. Now the first thing we have to do is to write down all the parameters that we have. Then from there we can go on and see if we can solve the problem. Now we were told that a plastic block of weight 25 newtons. So our weight, okay, which is equivalent to our force, is given to us as 25 newtons. So we have 25 newtons, and then we've been given a dimension of the plastic block. So the dimension is 34 centimeters by 25 centimeters by 10 centimeters. Okay, so let's try and draw the box. So let's say this is our box. Let me draw something over here very quickly. Okay, so let's assume this is our box. Okay, so I'm going to use this side over here. Since it's the longer side, I'm going to give that the 34 centimeters. Okay, so I'm going to give the height over here the 25 centimeters, and then I'm going to give the width over here. I'm going to give that the 10 centimeters. Okay, now if we look at this particular block, we realize that we can have quite a couple of areas for this particular block. So let me denote that with a different color. So we can have area 1. So this surface, we can have here the surface over here as area 1. We can have the surface over here as area 2. Then we can have the surface at the top over here as area 3. So it means we have 3 different areas for this particular surface. Now, in order for us to calculate the pressure that each of these surfaces can exert on the ground, we first of all need to calculate the area of these surfaces. So let's go ahead and look at area 1, area 2, and area 3. So calculating area 1. So area 1 is equal to length times breadth. And if we look at it, for area 1, we are dealing with the length, which is 34 centimeters, multiplied by the breadth or the height, which is 25 centimeters. So we have 34 multiplied by 25 centimeters. That will give us 850 centimeters squared. Now remember, we said that the area is supposed to be in meters. So if you like, you can convert the 34 centimeters to meters first, then the 25 centimeters to meters first before you do the multiplication, and then you get your answer. Else, you would have to convert 815 centimeters squared here to 2 meters. So let's look at that. We know that 100 centimeters is equal to 1 meter. So if we want to have meters square as our answer, we will have to square 100 centimeters. We square this side, then we square 1 meter as well. Okay, so sorry, the square is supposed to be outside. We square that as well. So this will give us 100 times 100, which is equal to 10,000. This is equal to 10,000 centimeters squared is equal to 1 meter squared. Okay, so this is the conversion to change from centimeter square to meter square. This is our conversion. So you divide by 10,000. All right, so using that conversion, if we convert the 850 over here, we divide it by 10,000, we are going to get 8.5 times 10 raised to the power minus 2 meters as the area for area 1. So let's look at area 2. So for area 2, we'll have length times breadth as usual. For area 2, we can see that the length over here is 10 centimeters. The breadth is the 25 over here, which is the 25 here as well. Okay, so we can have 10 multiplied by 25, 10 multiplied by 25, and that will give us 250 centimeters squared. We divide that by 10,000 and we get 2.5 times 10 raised to the power minus 2 meters. Alright, let's calculate area 3. So for the third area, which is at the top over there, you see that the length over here is 34, and then the breadth over here is 10. So we have length times breadth, that is equal to 34 multiplied by 10, that is equal to 340 centimeters squared. Then if we convert that to meters, we'll have 3.4 times 10 raised to the power minus 2 meters squared. Meters squared, meters squared. Okay, so that is our area for area 1, area 2, and area 3 as shown in the diagram over here. Now that we have the area 1, area 2, area 3, let's proceed to calculate the pressure that each of these surfaces can exert on the ground. So let's calculate pressure 1. So pressure 1 will be equal to the force or the weight on area 1. On area 1, this will be equal to the force we were given to 25 newtons. On area 1 is 8.5 times 10 raised to the power minus 2 meters squared. And if we compute this into our calculator, we get 294.12, which to the nearest whole number is 294 Pascal. So the unit for measuring pressure is Pascal or Newton per meter square. So our answer over here is 294 Pascal. Let's look at pressure 2. So for pressure 2, we have the force on area 2, and that will be equal to 25 on the area 2. The value we have is 2.5 times 10 raised to the power minus 2. And then if we compute this on our calculator, we are going to get 1,000 Pascal. So 1,000 Pascal. Now let's calculate pressure 3. Pressure 3. That is the pressure exerted by the surface area A3. So we will have force on area 3. So this is equal to 25 as the force on area 3. Area 3 is equal to 3.4 times 10 raised to the power minus 2. If we compute this into our calculator, we are going to get 735.29. So the nearest whole number is 735 Pascal. Right, so now that we have our answers, let's try and answer the question. So the question is saying, what is the greatest pressure and the least pressure? So if you look at it, we have 294,000 Pascal and then 735. So we realize that the greatest pressure is the 1,000 Pascal, and that is exerted by area 2, which has the area 2.5 times 10 raised to the power minus 2, which is literally the smallest area over here. So we say the smaller the area, the higher the pressure. So it makes sense that because the area is very small, it will exert the highest pressure. All right, let's look at the area with the least pressure over here. So if we look at that, between 294 and 735, definitely 294 is the least pressure. And if you look at that area is 8.5 times 10 raised to the power minus 2, which is the greatest area exerted by area 1. So we can see that area 1 has the biggest area. It has the biggest surface area. Because the area is big, the pressure that it will exert is quite small, and hence the reason why it has the smallest pressure. And if we look at area 2, area 2 has the smallest area, as we can see from the illustration, and hence the reason why it has the highest pressure, because the relationship between area and pressure is inversely proportional. All right, so let's have a look at another example to further appreciate what we are doing over here. Right, so we have a box of size 20 meters by 4 meters by 5 meters and has a mass of 120 kilogram. We are to calculate the least pressure that it exerts on the table, and II, the maximum pressure that it exerts on the table. So let's proceed with our solution. So let's write down our solution. All right, so we have a box of size. Let's write down the dimensions. So the dimensions are 20 meters. So likely we were given the dimensions in meters, so we don't need to convert again. And then we have a mass. The mass is equal to 120 kilogram. So we're told to calculate the least pressure and the maximum pressure, and then we're given gravity to be 10 meters per second squared. We know that pressure is equal to force over area. And then we know that force is equal to mass times acceleration due to gravity. So we can say pressure is equal to mass multiplied by gravity all over area. That will give us our pressure. Now let's try and have a visual representation of the box that we have or we were given in the question. So let me draw something very quick. So let's say this is our box. Okay, so this is going to be our 20 meters for the box, and then we have here to be our 4 meters, then we have here to be our 5 meters. Okay, so from the diagram we can see that let's make here area 1, let's make here area 2, and let's make here area 3. Now you can name the surfaces how you want, but make sure you know the result to multiply to get the area for each of those components. All right, so let's calculate the area for area 1. So for area 1 will be equal to length multiplied by breadth. And if we look at the diagram, our length will be 5, and then our breadth will be the top one over here, which is the 4 we have over here. So here to here is also 4 meters. So our area 1 is 5 by 4, and this is equal to 20 meters squared. That is our area 1. Right, let's look at area 2. Area 2. So area 2, we use the same formula, but our components to multiply will be different. So if you look at area 2, we have the length, which is 20 meters over here, and then the height or the breadth is 4 meters over here. So we have 20 multiplied by 4, and this is 80 meters squared. Right, let's look at area 3, the one at the top. Area 3. So this is equal to length times breadth as usual. But if we look at it, the length for area 3 will also be the 20 over here, but the breadth over here is this component over here, and that is 5. So we have 20 multiplied by 5, and that is equal to 100 meters squared. Now from the look of these areas, based on the area, because the force exerted is going to be the same, we can conclude on which area will have the highest pressure. So if you look at it, the smallest area here, 20 meters square, is expected to have the highest pressure, and then the highest area here is supposed to have the lowest pressure based on our understanding of pressure, the formula, and then the relationship between area and pressure. So let's see if this is actually true. So let's calculate pressure 1. So pressure 1 will be equal to Now let's calculate our force separately, so we just use it. So our force will be equal to mass times gravity, and that will be equal to our mass is 120 kilogram multiplied by our gravity, which is 10. So this will be equal to 1200 newton. So this is our force. So our force is 1200. Right, so our pressure 1 will be force over area 1, and that will be equal to 1200 on 20. Okay, the 0 cancel, the 0 is left with 120. 2 will go into 120 60 times, so we have 60 pascal as our pressure 1. Now let's look at pressure 2. So pressure 2, we have force over area 2. Now our force is still the same, 1200 newtons on our area 2. We have over here is 80, so we have 80 here. 1200 divided by 80 will give us 15, so our answer is 15 pascal. Now let's calculate the pressure 3. Pressure 3, we have the same formula, force, but the area will be area 3. So this is equal to 1200 on our area 3 has 100 centimeters, 100 meters square as our area. So 1200 divided by 100 will give us 12 pascal as our pressure. So if we look at the results of pressure 1, pressure 2, and pressure 3, we realize that pressure 1 has 60 pascal, and it is the highest pressure, and the area over there is 20 meters square, which is the smallest area that we've seen among the three area 1, area 2, area 3. So like I said, the smallest area will have the highest pressure, and that is what we can see over here from the results. So the I aspect, the II, which is saying the maximum pressure that is on the table, that maximum pressure will be from area 1, which has the smallest area, and that value, the pressure over there, will be 60 pascal. Now the I aspect, which is saying the least pressure between 15 and 12, 12 is the least or the smallest, so the least pressure is going to be 12 pascal, and it is exerted by the area 3, which has the highest surface area. All right, let's have a look at one final example, and then we end this beautiful tutorial. So the last example for this particular tutorial, we have a rectangular block with size 20 centimeters by 12 centimeters by 4 centimeters. It's made of a material of density 2 gram per cm cube. Find the minimum pressure it can exert when resting with one of its faces on a horizontal surface. All right, so let's have a look at the solution to this problem. Now we have a rectangular block with dimensions, so let's write down our dimensions. So our dimensions are 2 centimeters by 12 centimeters by 4 centimeters. And then we're told that it was made of a material with density. So the density represented by rho is equal to 2.0 grams per cm cube. We have to find the minimum pressure it can exert. All right, let's look at something. Now, in order for us to calculate the pressure, we need the force over the area. Now we know that from the dimensions we can get the area, so we don't have a problem. But the force, we can't find the force because we're given density. So let's break down force. We know that force is equal to mass times acceleration due to gravity. So we have mass multiplied by gravity, okay, on area. Now gravity, we know that gravity, okay, is approximately equal to 10 meters per second square. Okay, so which means that among all the parameters we have, or we are lacking, we have gravity, we can find the area, and then we are missing mass, so we need to find mass first. Now how do we find the mass? We know that density or rho is equal to mass over volume. Now if you look at it, we have the density we're given, but we don't have volume. But we can get the volume of the block by using the dimension, multiplying all of them to get the volume. And then now that we have density and we can calculate the volume, we can easily find mass. So if we make mass the subject, over here, mass will be equal to the density multiplied by the volume, and that is equal to, the density is 2, so we have 2 there. Because the unit is in gram per cm cube, not kilogram per meters cube, I will not convert the density to kilogram per meters cube. I will maintain it like this because the units can cancel. So I have here 2 gram per cm cube, okay, multiplied by the volume. The volume will be equal to, into bracket, 2 multiplied by 12 multiplied by 4. So this is equal to 2 grams per cm cube. I want us to look at something. Multiplied by 2 multiplied by 12 multiplied by 4 will give us 96 cm cube. Sorry, cm cube, not negative, just cm cube. Okay, so from here we realize that the cm cube over here will cancel the per cm cube over here. So we are left with 2 grams multiplied by 96, and that will give us 192 grams. So this is our mass. But we know that for us to calculate density, our mass has to be in what? In kilograms. So we convert 192 grams to kilogram. To do that, we divide by 1,000. So if we do that, our mass will now be 192 divided by 1,000, and that will give us 0.192 kilogram as our mass. Right, so now that we have our mass, let's go ahead and calculate our force. So our force, which we said over here is mass times gravity, is again the same, mass times gravity. So let's look at our mass. Our mass is 0.192 multiplied by gravity, which, even though we're not given, we know is 10. And so if we do that, this will give us 1.92 newtons as our force. So now we are able to find that our force is equal to 1.92 newtons. All right, so now that we found the force, let's go ahead and calculate the areas, the possible areas from this dimension, and then we go ahead and calculate the pressures. Okay. Okay, so let's proceed. Now I will not be drawing the symbol or any diagram in this case, but let's calculate the area without necessarily drawing the illustration. So we will have area 1, which will be length times breadth. We will have area 2, and then we'll have area 3 as well. Now all of them will be length multiplied by breadth, length multiplied by breadth. Now for the first one, we can use 2 and 12 as the first one. So for area 1, let's say we have 2 centimeters multiplied by, now let me convert them straight to meters so that I don't have to convert later on. So the 2 centimeters, if I convert it to meters, it will be 0.02 multiplied by the 12 will become 0.12 meters, and then the 4 will become 0.04. okay, all of them is in meters, so this is their conversion. So area 1 will be 0.02 meters multiplied by 0.12, so I have 0.02 multiplied by 0.12, and that will give me 0.0024 meters squared. All right, let's look at area 2. Area 2, I still use 0.2, but I multiply with 0.04. So I have 0.02 multiplied by 0.04, and then that is equal to 0.02 multiplied by 0.04 will give me 0.0008 meters squared. Now if this multiplication I'm doing here is confusing you, you can draw a box yourself or a rectangular block and then give it the dimension yourself so that you know what to multiply. Now the last one will be between 0.12 and 0.04, so that will become 0.12 multiplied by 0.04, and that will give me 0.0048 meters squared. This will become my area 1, area 2, and area 3. Now if you look at these values, you realize that 0.0024, 0.008, and 0.0048, the smallest area among these guys will be 0.0008, and therefore it means that the 0.008 will be the one to exert the greatest pressure. Now if you look at the question is asking for the minimum pressure. So it means the minimum pressure, to get the minimum pressure, we need the surface area with the highest surface area. So if you look at it, 0.0048 will be the one to give us the minimum pressure. But let's go ahead and calculate the pressure 1, pressure 2, and pressure 3. But some students will just go ahead and make the deduction that because pressure is inversely proportional to the area with the highest surface area will give us the least pressure, and hence area 3, which has the highest surface area, will give us the minimum pressure, and then they will just do that calculation straight. But let's go ahead and see that for ourselves. So let's calculate pressure 1, which is equal to force on area 1, and the force we calculated earlier was 1.92 newtons on area 1, which is 0.0024, and that, if we punch that into our calculator, we are going to get 800 Pascal as our answer. Let's look at pressure 2. Now pressure 2, we will have force on area 2. Now this will give us 1.92 newtons for our force, and then our area is 0.0008, and then this will give us a pressure of 2400 Pascal. Now let's calculate pressure 3. It will be force on area 3, and that will be equal to 1.92 newtons on 0.0048, and that is equal to 400 Pascal if we punch that into our calculator. So if you look at the three pressures that we have over here, the minimum pressure among these three is 400 Pascal, and that was given to us by area 3, which has the highest surface area. So the highest surface area gave us the minimum or the smallest pressure. Like we said at the beginning of this video, we said that the higher the pressure, the smaller the surface area, and then the higher the surface area, then the smaller the pressure. So thank you so much for watching this video tutorial on pressure. If you like it, consider subscribing to the channel, like, share with your colleagues, and then I will see you in the next video. Bye bye.